Now. Okay, so hey everyone, here's our second lecture. Today we're talking about climate change. We're also just going to be talking about changes more generally in the environment, something that we'll expand upon tomorrow and also on Thursday, in talking about the sixth mass extinction of life on Earth, also known as the Holocene extinction. Which is tomorrow, and then on Thursday we're talking about the Anthropocene. Today we're talking about climate change, and we're also going to be talking about environmentalism around campus, actually, something that I like to return to throughout this course because we as UCSB have a really interesting history of environmentalism and also literally environmental studies. This is an intro to environmental studies, but we were one of the first programs to really have such a um, multidisciplinary focus that is both in the humanities, so the BA, but also in the sciences, the BS, programs that some of you all may be in. So we're going to be talking a little bit about that. Then we're going to talk about, why changes happen, just kind of a briefer overview. And then we'll get into some stats about climate change. Then we'll talk about I'll take any questions that are put in the chat or just raised in person after. Those are our orders for today. So let's get into it. Oh, okay. So I wanted to introduce you to my animals. For some reason, Buddy is fine during this class, so you hopefully, by the grace of the universe, you will not hear him barking, but he's the one on the right, the red-haired dog in my teenage bedroom. So don't mind the accoutrement. In the middle there, the middle pup is Henry. He is 2, Buddy is 6. They are best friends. I like to think about them running across the yard and parks and wherever to the music of Robin Hood and Little John from Disney's 1962 classic. And then to the left, I have 2 of my 3 cats. The tuxedo on the far left is Essie, and the one looking demurely at the camera is Lando. They are both 6. They are joys and delights. Not featured is my 3rd cat, Mew Mew, and that's because he's an international super spy, and he just preferred to not be pictured. So those are my animals. And if you have any interest in, I think I talked about this yesterday, but if you have any interest in having your animals reviewed by me with many endearments, or any pets that you have, could be plants, could be rocks, I will set up a little forum at the top of our page for you to share your pets with us. I think that's very important and a nice way to try to build community over appreciating our pals that get us through rough times. So getting into lecture, I want to really think about how UCSB in particular has stakes in environmentalism and environmental studies. So hopefully you watched the video put out by the department that I have in our syllabus to be watched this week. And then I also have a short piece that you could either read or listen to about the Santa Barbara oil spill. But this is a great place to kind of start in thinking about what does it mean to study the environment, and also why is it important, or why is it a really cool opportunity to do so at UCSB. So hopefully you all read about the Santa Barbara oil spill. It happened 52 years ago now, in 1969. It happened really close to where campus is, which you can see on this map. So the biggest part of the oil spill was in this area right here, a little north of Carpinteria. If you've been around there, that's around Summerland. They've had a couple really bad oil spills since, but at the time in 1969, this was one of the worst oil spills to have ever ever to have ever happened. So this happened, it was a blowout on January 28th, 1969. Um, it happened because of a rupture in the channel floor. And so you have raw oil and gas just seeping, just oozing from this oil infrastructure. So keep in mind that the California coast, if you haven't like maybe been to the Santa Barbara Maritime Museum, which has a small exhibit on this, or if you haven't been to maybe like Coal Oil Point yet, and sometimes during normal times they have tours. I've given a couple. Or if you haven't been to some of the more local Santa Barbara County beaches, they'll talk about it too. The Santa Barbara coast is a really oily place. We have millions of tons of oil come like under the water of our coast. This is for a couple reasons, one of which is our geology has made it possible for a lot of oil to collect. There are places for it to bubble up. But what is bubbling up? What is oil? But dead, very long dead flora and fauna. So we have this, hundreds of thousands years old, if not if not more, natural biotic material. Oh, all right. Make sure that you're muted. But it's cool. Hope everything's okay. You have, just all of this oil oozing under, actually pretty close to the ground, at least at first in 1900. That is when you have oil, what later became the oil industry, gets started in Santa Barbara, in Summerland. There are some massive pictures of all of a whole bunch of different wharves where they would basically take a really long stick and poke it into the ground and keep poking it until they struck oil, and then they would use a siphon to take it out, and then it would be processed on the shore. And in 1900 and 1920 especially, almost the whole county of Santa Barbara's coastline was just covered in these stocks. There were some spots like in Carpinteria, they had a little bit more of a tourist scene that started before 1920. Same with Santa Barbara, like downtown Santa Barbara's coastline. But for the most part, there were just all of these wharves with lots and lots of oil just being siphoned out and then being processed on land. In 1920, with the boom of early tourism, especially for richer folks, going into the World War II, with worries of attack from Japan, which was, the California coastline was one of the closest places for Japan to attack the US. There was a lot of concern on the coastline. A Japan submarine actually attacked the Goleta Slough area, so right by campus. I can't remember the year. It was near the end of the war. They did some damage, but no one died. But that was an attack on US soil. Technically, even though it was more or less a mistake. It's a very interesting history. Anywho, but because of those worries and concerns during the war, there wasn't a lot of oil infrastructure during the war. Then it started to come back in the 50s and 60s as the population began to boom after the war, with baby boomers, as we know, and just the need for oil, and oil not just for gasoline, but to make oil products, which is most of the plastic things that we know today. And we've become more and more dependent on oil. And so Santa Barbara, this beautiful place, also a very oily place, had been overcome again with much nicer, much at least thought to be at the time, much stronger infrastructure to take out this oil. And it did not go well, as we can see here. So between January 28th, 1969 and February 1st, 1969, you have a massive amount of oil just completely, oozing out of the coast of Summerland and spreading as far down to Oxnard and as far up as, let's say that would probably be around like El Capitan, so about 10 miles north of UCSB, going all the way across to the Channel Islands that you can see here, which are about 26 miles away from the Santa Barbara shoreline. So it spread out, created a lot of not only concern, but just it made people there was already a lot of bubbling, pardon the potential like oil extraction pun there was a lot of bubbling concern in the late 50s and 60s about environmentalism. We'll talk about Rachel Carson tomorrow, but people were already seeing scary changes in the land that seemed like they were coming from like a dystopian like sci-fi movie, because science fiction started to really gain traction during this time as well. There's a lot of worry, a lot of concern, and this just it seemed like a hellscape. And there are multiple reasons why Santa Barbara oil spill became a really important time period, like a flashpoint in this history. But there are some other reasons, and I'll get into some of them right now. So this became a different environmental disaster because of media access. So whereas other environmental disasters maybe were not so easily understood, were not so easily accessible to different audiences besides the local, the information about this oil spill, pictures of the oil spill, pictures of how it impacted the flora and fauna, comics and commentary, etc., became, oh, make sure that you're muted. All of this became much more accessible, not just to national audiences, but international audiences. And by the next year in 1970, very much inspired by the Santa Barbara oil spill, we actually have the first Earth Day, which is April 22nd. There's also a difference in here, which is the strange place that Santa Barbara, especially at this time, rested with politics. So here we can see Nixon. I couldn't find, there's this really fun picture that I found in UCSB's special collections that I haven't been able to find anywhere else, but there's this picture of Nixon jumping or attempting to jump over different gobs of oil that were on the beach, because he came dressed very very much like a politician, in very nice shoes that he didn't want to get dirty. But we have Nixon, a native Californian. He actually was born in the city that I am coming to right now. He was born in Whittier, California, which is only 120 miles south of this place. He was a Republican, very conservative, but he felt impelled to do something. Other Californian politicians at the time, not pictured here, would definitely be Ronald Reagan, who pushed forward some environmental politics, but really didn't. And we could talk more about that when we get to politics. But all of this is to say is that there was a lot of pressure due to where Santa Barbara was, how much money it is and has been in Santa Barbara since California became a state in 1850, plus many mainstream, very active politicians, including Nixon, which you can see right here, um, making it possible for Santa Barbara to be taken, and its oil spill to be taken more seriously than other different environmental catastrophes. So during that year as well, the Cuyahoga, I can never say that right, but in Ohio, a whole river caught on fire on fire because of industrial pollution. But it even while that seems even more like a hellscape, at least to my imagination, than Santa Barbara's still really awful oil spill, Santa Barbara was the one that caught the most attention, partially because of actual politicians, but of course, race and class can't be ignored here. There were a lot of settling white people among, uh, other folks who maybe were not able to be as loud about the injustice that was happening for so you have a lot of angry white people in Santa Barbara, whereas you who have money, whereas in Ohio you have potentially less of that, and you have more people of color being directly impacted. So politics were definitely an issue, but so were protests. So Santa Barbara was one of the second school, I think it was the second school in on the West Coast to really um, dive into the politics of the late 60s and early 70s, right after Berkeley. UCSB had a lot of opinions about Nixon's involvement, which you can see here. So Nixon president is oil king. The South Coast is dying. Lots of concerns about environmental issues, along with race issues, class issues, and of course the war in Vietnam at this time. So much so that, along with the local Sierra Club and the Los Padres Forest, you also have a group called Get Oil Out, or GOO, in Santa Barbara, which I'm unsure if they're active today, but they were a really major force and have been a really major force in promoting oil leaving Santa Barbara. Let's see, we got a chat for that. Okay, awesome. Cool. Another thing that made this a special kind of circumstance is that there were, like I hinted at before, a lot of corporate interests at the time. So you can see here some of the different companies that were working at the time of different spills. So you can see the 2015 spill, which started right around. I am my mind is blanking on the name, even though I have been there before. But to the north of campus, you have the 1969 spill, which you can see here. But so even though this is a more contemporary map, you can see all of these different oily infrastructures that made it possible, but also uh, brought up a defense against those protests who were in action. So it wasn't kind of granted that even though Earth Day happened and environmentalism really started to take place through UCSB and in the Santa Barbara community more generally, it wasn't like Santa Barbara was ever able to become an environmental utopia. And of course, even though Santa Barbara oil is starting to shutter, especially and shut down, especially in the last few years, as money has been more directed to more green or renewable or sustainable technologies, we still have hundreds of thousands of wells off of our coast. And it's just really scary to think about how another one of these spills will happen again. I mean, as you can see, 2015 was only 6 years ago, and I remember how catastrophic that was, even though it was much smaller than the 1969 oil spill, which still today is only the is now the third largest spill rather than the first. And another thing that I hinted to was the location. So as you can see, Santa Barbara had a big surfing culture, as you can see here with this young person who's covered in oil both on his person and on his surfboard. But you can guess that under that tan and under that oil, he is white. Whiteness is definitely a factor in when we talk about environmentalism in Santa Barbara. Um, you have a lot, there are different kinds of environmentalisms, which we will get to in this class. But that is something to really be cognizant of whenever you're thinking about environmentalism in any place. What positions of power, what intersections of power do these people who are experiencing environmental justice or environmental injustice, what are their positions? So we can see this oiled up hippie making a point that even the largest oil spill in the world, at least at that time, wouldn't stop him from catching a good wave. So I bring all of these up because media, politics, location, of course, all of these different things that I covered are part of the ecosystem as well. So when we're talking about ecosystems in this class, when we're talking about, and you might not be able to see me right now, but in scare quotes like nature or wilderness, environment, even, it isn't just flora and fauna. It is people. It is the cultural baggage that they bring to it, as we will be talking about over the next 2 days, but also the rest of class. People are part of the environment. People are part of the ecosystems, especially in the Anthropocene, which, like I said, we'll talk about later this week. Even though that is a more recent development, even before then, even before the Industrial Revolution or the migration of people from Africa, which, depending on who you talk to and who you read, those are the defining times for when the Anthropocene started. Even before that, though, people are part of the ecosystem. And as we look at these different examples, I think it's throughout the course, I think it's really important for you to pay attention to that. And when we talk about different environmental justice issues, when you write about environmental justice issues for your final, these are things that you'll want to consider as well. So I hope that that was a useful kind of primer to our, being UCSB's, kind of local historical ecosystem. Of course, it's so much bigger. We have a long history of fisheries. We of course have the Chumash people who have been on the land for 9,000 years at least. We have different forms of resistance that have long happened before the 1969 protests on this land on behalf of the environment, and also on behalf of just autonomy more generally. This is just a quick flashpoint, but because of this moment, that is a big reason why UC Santa Barbara created the environmental studies program in the 1970s, and why we're all here today. So I just wanted to make you aware of that history. I think is really interesting personally. And if you have any more follow-up questions to it, I have lots of resources. I worked on a digital field guide a couple years ago of oil in Santa Barbara. If anybody's interested, it's kind of a digital tours that you can take, either online or when you go to a place, you can look up different points of interest. But all of that is to say is that natural extraction is also part of the ecosystem as well. What we do how people, how other animals, how natural forces change the land are all kind of in conversation together and making ecosystems what they are. So, like I said, UCSB created environmental studies in the 1970s. Besides having our awesome department, which you are taking a class from right now, they have all sorts of different activities and the I am blanking on the word. There are different events, there you go, that you can go to during the school year. This was one in 2019 that I personally worked on, but there are tons of other things that, especially when campus is open, that especially environmental studies, but there are different groups on campus that, create events for our local community, both campus and otherwise, to participate in and learn together. So that's something to kind of be aware of, whether you are a major or not yet. So before we get into what climate change is, we also have to consider this bigger question of why do environments change? So related to this, how do people view environmental change in different disciplines? What are some key concepts for thinking about environmental change? And we're going to be talking about the non-human ones today, and we will be talking about the human ones tomorrow and on Thursday. But in order to understand the environmental crises we're in, we have to understand how they started in the first place. So this is kind of an overview of different reasons why environments change, not considering directly humans enacting that change. The biggest one is geology. So this is an engraving that depicts unconformity in sedimentary layers by Jedburgh, Scotland. So this was published in one of the earliest geologic books to date, which is James Hutton's Theory of the Earth, Volume 1. This is at the end of the 1700s, 1795. And it suggested, that should say bucolic, which means kind of like cottage-like, that this bucolic region had experienced major upheavals during its long geologic history. So when we talk about history, in the field of history, there can be different conceptions of what is historic and what is not. I ascribe to, especially as an environmental historian, I ascribe to a view of something called deep history or big history, which takes account for these different natural forces, non-human forces, especially geology, which is soil. I don't know if anybody, I'm not going to go into a soil tangent, I promise, but soil, while it sounds really potentially boring, they are rich kind of archives in and of themselves. What kind of sediments and minerals and everything else and even little rocks that you can find in the soil make plants possible, which in turn make animals possible, which in turn feeds other animals, which in turn, helps sustain the ecosystems that as we know them. But geology is a massive aspect to this. So this first early example shows that, changes in the land, which environmental historian William Cronin uses a lot, this idea that lands change, that things aren't static, that we are working within a system. Geology was one of, at least in 1795, this was one of the first moments where people began to think, maybe everything isn't always like this forever. Maybe there is more to it than before I became a person. Maybe things change after I'm gone. which sounds, I mean, of course, people were aware of, some changes, especially changes in season, trees growing, crops living and dying. But the idea that there was more to it than just that really started with James Hutton's theory of the earth. So here are some examples of different kinds of geology, both in Arizona. I will say one is cooler than the other as far as tourist stops go. But with the Grand Canyon, we can see an idea of uniformitarianism, a word that always has trouble coming out of my mouth. And this is that the same slow processes have always shaped life on Earth and continue to do so today. So this idea was put forward by Charles Lyell. You may recognize that name from readings today, and you will see his glacier later. But there was also this idea of catastrophism that, which we can see here in Meteor Crater, also in Arizona, which is the belief that Earth history is shaped by, that should say rare, unpredictable, transformative events, and that was pushed forward by George Cuvier. And there have been lots of debates as to how geologically the world has been formed. And I will spoil it. I think it's on a on a slide coming up soon, but I will spoil it, and I'll say that we can see through these examples just in the same land that is now known as Arizona. We can see that there's both. There was slow processes cutting through this sediment to create the Grand Canyon. But if you go to Meteor Crater, Arizona, which is overpriced, but and doesn't have the best documentary feature explaining their thing. I'm not biased at all. But if you go there, if you visit, and if you pay the money to go, they will tell you the history of a meteor coming and crashing down and creating that big old hole that you can pay $30 to see. It is pretty impressive, but not worth $30 in my opinion. No shade to anybody who really loves Meteor Crater. Another factor that we have to consider with changing landscapes is also evolution. So we can see here Charles Darwin, famous for his beard and, dare I say, like delightful eyebrows. But by the mid 19th century, so geology, and then with Lyell and Cuvier being later in the earlier in the 19th century before Darwin, most naturalists were embracing a more dynamic view of nature. So they knew environments changed, but they did not know why or how. And then we have Mr. Darwin here, attempting to explain why. So here is a sample from words that were in Alfred Russel Wallace's journal from around 1855. So Wallace was the co-author with Darwin of the first paper that introduced the theory of evolution by natural selection. So I'll just read it for you. Some species exclude all others in particular tracts. Where is the balance when the locust devastates vast regions and causes the death of animals and man? What is the meaning of saying the balance is preserved? Are the devastations of the sugar ants in the West Indies and the locust with which Mr. Lyell says have destroyed 800,000 men an instance of the balance of species? To human apprehension, there is no balance, but a struggle in which one often exterminates another. So so we see here again this appreciation that change does happen in the environment, but also some existential questionings as to what that means, if and how does that fit with religion, and how does that fit with morality. And there's there are some kind of scary consequences that come in the decades later, in the form of eugenics in particular and different adaptations of natural selection and evolution in ways that neither Russell Wallace or Darwin intended. But in the exploration of species changing, whether it's flora, fauna, and as eugenicists try to apply to people, we see that there are also these other natural forces that are changing the landscape, are making it possible for species to change with the land and to keep up with different and other natural processes that are happening, whether it be through earthquakes, whether it be through um, non anthropocentric, non human started fires, whether it be through different climatic changes that happen over time. We'll get to global climate change still, but these are things to consider. Evolution and the understanding of it is another way that we can understand environments changing. Oh, sorry that the text looks a little blocked here, but I want to say that evolution also evolves. And so we have two models in evolutionary biology that depict different rates of patterns of change, and they also imply different underlying processes. So you have phylactic gradualism, which is small variations happening over time to produce larger changes in plant and animal species, so populations responding to natural selection, and that's closer to our friend Darwin. But we also have punctuated equilibrium. So during normal periods, little change occurs, but occasionally major shifts lead to rapid evolutionary changes. So that's Stephen Jay Gould, who is a bit later than Darwin. But you can see here with both gradualism and punctuated equilibrium, kind of a hearkening back to the distinction between uniformitarianism and catastrophism. You have something happening slowly over time, and then you have a punctuation, a quick stop that where a major shift happens. So let's talk a little bit about climate. So there are two hypotheses. I guess two hypotheses to explain climate. So historically, we have the Gaia hypothesis, which is Earth's atmosphere and biosphere comprising a stable, self-regulating system that has endured for millions of years, and that was made famous by James Lovelock. Ooh. And then we have chaos theory, which is, both of these are great names in my opinion, but chaos theory, where future outcomes depend on the conditions of today. The climate is prone to unpredictable changes, and that was made popular by Edward Lorenz. We'll talk about both of these tomorrow as well, but I just kind of wanted to flag them right now. Also, ecology, just the general workings between different parts of a land working together, ecosystems. Make changes in the land that don't necessitate human involvement. So right here you can see an example of the North Woods in New England. So which looks a lot better than our Coast Ranges on Fire in California. That looks very similar to things that I've seen on the 101 during fire season. Very scary. But these are different kinds of ecosystems. So with the Northwoods, you have disturbed ecosystems passing through predictable changes, reaching a final climax state determined by climate and soils. And so that was the work of Frederick Clements, who actually did a lot of work around campus. Actually, in the late 1890s, he was a friend of John Muir and also Elwood Cooper of Elwood Mesa that I talked about earlier, and you can see an exhibit of him at Coal Oil Point. But that's a bit of so his idea of ecosystems looks a little different when we consider the coast ranges of California, because disturbance can be the norm in most ecosystems, and that can result in unpredictable, even irreversible shifts in certain tipping points. So there are times and there are places that are less prone to these disturbances, or disturbances are, brought on by seasons. So as we can see in the beautiful foliage of New England, in comparison to California literally being on fire. So I've given you a lot of information. Okay, cool. What's the point? So the biggest takeaway I want you to have from this is that the environment is a complex system of systems. It is always changing in different ways for different reasons at different scales. And how can we measure all of those changes? Well, there's a lot of ways. Here are just some of the uses of evidence that have been used to study environmental change. So you have sediments. So I talked about geology, also ice cores, pack rat middens, tree rings, of course, need to bring up my favorite, archaeological remains, written records, old scientific data or specimens. So images, we'll see an example of rephotography in a minute, and hopefully you read about some today and what remains. Related to that is long-term or repeat field studies. So a lot of those also use rephotography. And now with technology, we have computer models that can actually help us try to predict what kind of changes in the land will happen as different factors, especially global climate change, but also different industrial and extractive developments happen in certain places. So what are some of the natural causes of environmental change? So we talked about some of these, but extraterrestrial impacts. So thinking about meteor crater, planetary orbital cycles. We talked about geology, so geologic or tectonic processes, evolutionary change, climatic cycles, random weather events, population dynamics among animals. We will talk about people tomorrow. These are just some. So again, why do environments change? So people have always understood that environments change until the 18th century, as you could kind of see with remember with our Hutton example. Until the 18th century, most Western thinkers believed that environments tended towards a balance of nature. And as humans, especially in the global West, did more studies of nature, they were able to see that it wasn't as balanced and as stable as maybe they once thought. And now we know that diverse factors inherent to the Earth system have transformed and continue to transform our planet on every conceivable scale. And ultimately, and I think that this is kind of beautiful, change is an intrinsic property on our planet of life on Earth, and even the universe itself. I am not an astronomer. I am not even close. But I have heard that it's even in the universe. So change is not always to measure or understand, not always easy to measure or understand, but hopefully in this class we're here to help. And so here are just some climate change basics. So hopefully your readings for this class have helped you kind of get I peeped in the chat. There's some stuff going on about punctuated equilibrium that makes me happy. So hopefully you read and watched some of the basic information on climate change. I wanted to just get into some more and just kind of when I finish up, open it up to any questions, and me or Billy or even your classmates can help make sure that we're all on the same page with climate change. Of course, we're going to be going through this throughout the whole quarter because climate change, depending on how you study it, depending on the place that you're in, depending on what resources you're looking at and how you're looking at them, we can understand it in a lot of different ways. But the fact is, it is global and impacts everything. So what is climate change and why is it happening? So here's a diagram. Take it in. Planets and so here is planets and atmospheres. I know I said I'm not an astronomer, but here we are in space anyway. So you can see Mars that has a thin atmosphere. Earth, our Earth has a bit more of an atmosphere. It has 0.03% of CO2 in it. And because of that, we have a much higher temperature than Mars. And Venus, which has a thick atmosphere, which contains 96% of CO2, has a much higher temperature than us, a scary temperature. So the thickness of the atmosphere and the concentration of its gases, especially CO2, influence the surface temperature of any planet. This is important, especially because our ecosystems as they are very dependent on temperature. As we will see, if the global temperature rises just a degree, we see drastic changes. So, oh, where did there we go. So keeping that in mind, we have to differentiate a little bit between global warming and climate change. So global warming is the increase of the Earth's average surface temperature due to a buildup of greenhouse gases in the atmosphere, whereas climate change, is related to global warming, but it's the long-term changes in the climate. So that includes average temperature and precipitation, and it recognizes that although average surface temperature may increase, the regional or local temperature may decrease or remain constant. That's why it's so these at times can be interchangeable, but climate change really more accurately describes what we're seeing. Of course, there is anthropogenic, so human-based activities that is exacerbating climate change, but also climate change is a natural process that was happening long before us, and hopefully we do not blow up this world, will happen long after us. This slide and looks way less cute than what I had it look like earlier. I'm sorry. So we're going to be talking about averages. In the last slide you saw, we're talking about average surface temperature. But when we're talking about average here, climate is the average weather conditions over time, where global warming refers to an increase in the Earth's average temperature. Okay, I hope that makes sense. If it doesn't, we'll talk about it. Here is a map that shows the 5-year average variation of global surface temperatures from 1884 to 2012. I assure you it has only gotten worse since in the 9 years since. So dark blue indicates area cooler than average, which you can see just a little of, but dark red indicates areas warmer than average. It looks like a treasure map. It is that dark and tea-stained looking. And this is all coming from NASA. The climate.nasa.gov is a great site if you want to spend more time with it. They have a lot of interactive maps that you can use and play with, and even better understand how climate change is impacting certain communities, not just the globe. So we have tons of evidence. The first one that we always go to is temperature and CO2 data. So knowing what we know about CO2 in the atmosphere, the greenhouse effect, we can see that the global temperature has raised. We can see, that graph is really rough. We can see that historical CO2 level is very scary and has been very scary since 1950. So we have that data. Again, this is both coming from NASA. We also have glaciers that are melting. So this is the Lyell Glacier that hopefully you read about and a little bit about and what remains. And this is a form of rephotography, meaning a photograph that is taken in as close to the same place as possible to see and be able to track changes in the land. And you can see between 1883, all of that snow, all of that white, all of that glacier. And in 2015, you see way less of that snow, way less of that white, way less of that glacier, and a lot of dry soil. So that's terrifying. Other data we have is the global sea level rise. So you can see here we have multiple changes in the sea. So it isn't just changes in the land, it is the sea levels are rising and they keep rising. And again, NASA has really cool charts to track your like local area as well. But yeah, all of these graphs keep going up, and that just makes my anxiety keep going up too. Why did it do this? Sorry. Oh, geez. Sorry. My PowerPoint decided to just put in random transitions. So when we're thinking about climate change in the US in particular, we have temperatures that are rising, especially in winter. I remember growing up in Southern California. Um, let's just say, I don't want to date myself exactly, but let's just say in the 90s, there were tons, like we actually had more seasons in Los Angeles, and now basically it is just hot all of the time. It is like we'll have some rainy days and then it's in the high 80s all the time, and then in the summer it's in the hundreds. Santa Barbara has more coastal breeze, but even there it is much more warm. We have extreme rainfall and flooding events, some lasting 24 hours, some lasting even like a week. And these are becoming much more frequent. We have droughts, 97.4, I hope I'm getting that right, percent of the state of California is now in drought, which is um, a sharp increase from only the 41.5% of the state that we were just last year. Because of this dryness, we have massive wildfires, especially when we're planting non-native or invasive species that are highly flammable, like eucalyptus, also black mustard, that really pretty tall stalk-like yellow flower that you can definitely see in Goleta, and you'll also see on some of the hills on the 101. Those catch fire like no one's business. Um, and so then we'll see, images like that picture I posted earlier of coastal California. This also there's a lot of talk about urban communities when we think of climate change and the infrastructure in urban areas like Los Angeles or New York that are impacted by a rising sea level, by temperatures rising, and then creating more need for infrastructure to have things like air conditioners running more often and all of the things to make urbanites more comfortable. But we have to think about rural communities who, maybe don't have all of that infrastructure to uh, remain stable. They find themselves much more vulnerable along with their businesses if they are in different businesses that require either logging or different kinds of extraction, but also, of course, farmland. And so climate change makes crops and food more scarce and expensive for everyone. Um, Also, corporations do that too, but we will get into that as we go along. Climate change, of course, is impacting plants and animals. So we can observe this through phenology, which is the study of events in nature. So for example, observing the date of the first snowfall or the arrival of a migratory insect or animals, and then comparing it to how, when that event happened later. All of these events are changing. Things are out of whack. And sorry, I'm getting distracted by the chat. Historic atmosphere of CO2 concentrations. Again, this is coming actually from Mauna Loa, which it's should not be operating, but we are getting good solid info, and we can see how, again, since 1950 things have just been on the rise as far as CO2, and a lot of that we will get into tomorrow, because it's people. It is people I don't know how to, I don't know the word I'm thinking of. I don't want to say people being people, but people being less attentive to their natural resource use. But it isn't just people, it's corporations that are benefiting from taking advantage of people wanting things to be easier. Again, we'll talk about that tomorrow, but also through the rest of this course. I kind of want to just end, I think, with this quote. I think this is the end with this quote. Warming of the climate system is unequivocal. Human influence on the climate system is clear. And we can see, with human influence, I've been kind of skirting around that, but I will say that we have a lot to talk about tomorrow and Thursday. And so for tomorrow, you're going to watch The Sixth Mass Extinction, which is a 50-minute documentary, and you're going to read a very short story. It's only 2 pages, called A Fable for Tomorrow by Rachel Carson. She is one of my personal heroes. And so we'll be talking about this sixth mass extinction, and we'll be talking, which also is called the Holocene extinction, and we'll be talking about the human motivated kind of changes in the land, again, that are coming about because of people. I'm going to stop sharing. I'm going to see if there is anything in the chat that I should talk about while filming, and then I'll make myself stop filming. We're talking about punctuated equilibrium. Beautiful, beautiful. Why is that the hottest places on the planet in the northmost of the planet? I'm not exactly sure what you mean, but we can talk after class. Okay, Madeline, you're talking. Okay, cool. Yes, our chancellor is involved in some of the controversial observatories in Hawaii that steals native land. Yes, we can talk about that in more detail. I just want to make sure that I am up to date with how that is going. But yes, UCSB has direct ties with the Mauna Kea Observatory, which is being operated on stolen native land. But honestly, all of the University of California is being operated on stolen land. We are always on stolen land. Well, at least I am. I don't know about you, but I am. Yeah, my white as snow. Okay, cool. Okay, I'm going to stop recording. I'm